Hello, let's review the review for functions and their inverses. Remember, this is my first and only take, so if I make a mistake, cut me some slack. Okay, number one. We want to isolate the cube root by subtracting 7. And that gives us the cube root of x plus 2 equals 2. We're going to do the inverse of the cube root by cubing both sides of the equation. That's going to reveal the x plus 2, and 2 to the third is 8. It is not 6. But when we subtract 2, there's our 6. There's the answer. On number 2, we're going to try to make them have the same base. Okay, the easiest way is to take this 4 right here and turn that into 2 squared. So it's 2 squared to the power of 3x plus 2, and that equals 2 to the power of 2x minus 8. We're going to take the power on the left to the power, which means multiplying, and that's the distributive property. So that would be 2 to the 6x plus 4, equaling 2 to the 2x minus 8. Now our argument is, if the left side and the right side are truly equal, then the exponents must be equal. So 6x plus 4 equals 2x minus 8. Okay, now through a series of algebraic steps, we're going to solve for x, taking away the x, and taking away the number on the side that will have the x. So we'll end up with 4x equaling negative 12, and that means x is negative 3. And there's our answer there. Okay, 3 is multi-parts. The first part is finding h of negative 1. H of negative 1 means substitute negative 1 wherever you see an x. And then we're going to use PEMDAS to evaluate. So 3 times negative 1, negative 3. And before we multiply with negative 2, we're going to square negative 1, and that gives us positive 1. And multiplying that by negative 2 is not going to change it, so we should just get negative 5. Now on our B part, we're going to place the f function inside of the g function. So the f function is x minus 3, so we're doing g of x minus 3. And the g function says to take 4 times parentheses something and add 1. But the something is x minus 3. So this becomes this right here. And we're going to simplify that with just combining like terms. We'll put negative 3 and positive 1 together, and then just multiply the 4 in distributive property. So 4x minus 8. And there we go. There's our expression. That is g of f of x. Moving on, next column. Easiest question in the world if you understand it. So input 7, output negative 5. Input negative 5, output 7. Back to 7. Okay, we're going to find the inverse here. Let's watch what happens to x. First, you subtract 1. Then you multiply by negative 4 in that direction. So we're going to reverse the steps, reverse order. The opposite of multiplying by negative 4, dividing by negative 4. The opposite of subtracting 1, adding 1. So what I would recommend you do is just write an x and then do these two operations to it. Divide it by negative 4 and then add 1 to it. And there's our inverse. Select all the statements that are true about the inverse. The inverse's domain is negative infinity to infinity. This is true because it's linear and there are no restrictions. The y-intercept is 0, 1. That is true. That plus 1 at the end means the y-intercept is 1. And the rate of change is 1/4 is false. Because, excuse me, that it's actually negative 1/4. So this is the same as saying negative 1/4 times x. Number 6, let's find the inverse again. Look at all the things that happen to x. First, you multiply it by 3. Then you add 1. Then you cube it. Then you subtract 4 in that direction. So we're going to reverse the steps, reverse the order. The opposite of subtract 4, add 4. The opposite of cubing is to do the cube root. The opposite of adding 1 would be to subtract 1. And the opposite of multiplying by 3 would be to divide by 3. So my inverse is, okay, just write an x and do these operations to it. First, add 4 to it. Then cube root it. Then subtract 1. Then divide by 3. And there we go. Next page, number 7. If you want to look up this Greg, in 1988 Olympics, his name was Greg Louganis. Won a bunch of medals. Okay, he performs a dive 90 feet. So his time is going to start at 0, and he's going to be at 90 feet when he does so. Now, if you keep going by ones here, you'll actually go down into the water. So you might want to try just doing halves. And we can do this on the calculator. So I have my blue calculator next to me here. Negative 16 times 0.5 squared plus 90. And that's 86. Now, when I replace that t with 1, that's just going to be 90 minus 16. That's 74. And then let's replace it with 1.5. We get 54. Now I'll replace it with 2. I got 26. And is this going to be enough to get us down to 0? Yeah, this is negative 10. So somewhere between 2 and 2.5 seconds, he hits the water. And so we can do a quick little graph of that. He's going to have to get up to 90. So how about 10, 20, 30, 40? And we're not going to make it, are we? 50, 67. No, we're not going to make it. Okay, see, this is a first take. So let's try go by 20s. How about 20, 40, 60, 80, 100? Okay, that'll work. And let's put a purple dot approximately on 90. So let's see, that would be 60, 80. That would be right about here. And then on the x-axis, we can do, I don't know, well, it happens really fast. So we could do every 4 is a 1. And that ought to capture it right there. So 0.5 is at 86. So that's right about here. And at 1 he's at 74. That's right about here, I think. 1.5, he's at 54. So maybe right about here. 2.0, he's at 26 feet. So maybe about here. And then somewhere in between there and the next one, he got down to -10. So maybe that's his splash down into the water. It is continuous. We can connect these together. There he goes. At what time is his maximum height? That's at the very beginning. At time 0, we would call that when you start the stopwatch. At approximately what time or times is he at 40 feet? Okay, so let's see. If we mark off 40 feet and we go, let me do this in another color. How about green? So here's 40 feet right here. We go over, we go straight down. It's about 1.5 seconds, a little more than 1.5 seconds. So maybe we could say 1.6. It does say approximately. What is the domain and range of h of t? Okay, so the domain, now, are we talking about when he hits the water or going under the water or what? Depends on how you interpret it. Like most teachers, I think, would say, when does he hit the water? That would be from 0 to about 2. Let's see, so it's less than 2.5. How about, let's say, 2.4? Now, the reason I would say go until he hits the water is that once he hits the water, the equation that describes his movement is actually going to change because the water is going to provide some resistance. The range went from 0 to 90, the platform's height. And the domain and range of the inverse, well, all we got to do is reverse these. And so put 0 to 90 here. And for the range, put 0 to 2.4 here. All right, not too bad. Done with that one. Let's move on to number 8. Graph the inverse. I don't know, I like purple for the inverse. I can reverse these points. So 0, -2, 1, -1, and 2, 1 are the reversals. Okay, and then let's also draw in the line y equals x. So it goes through the origin, here and here and here and here, goes through the corners of the box. Kind of show it with a dashed line. Okay, so down here, this point is also on the inverse, and so is this point up here. So it looks like the body of a cockroach. And then this one's going to look like it goes straight out, but actually it doesn't. It's an asymptote. You could zoom in and there will be a little tiny bit of separation. And then up here on the top, it doesn't go straight up. It doesn't curve back. It does sort of keep very slowly spreading out. Like about that. Okay, and then number 9, table of values is given. Find the inverse. Of course, all we have to do for the table is reverse the x and the y. So that's easy to do. What's not so easy to do is to figure out the equation of the inverse. But I'm going to do something a little sneaky. I'm going to get the equation of the original and then make it the inverse. So what we would have to do is project the table until you get to 0. So we're going up by 3, up by 3, up by 3. Actually, not up. We're actually going down. Down by 3, down by 3, down by 3. So that'll take us to negative 17. So the f of x, let's see, the slope of that would be that we're going down by 3 each time, and we're starting here at negative 17 is our intercept. And we are live with fourth period. Welcome to the podcast. All right, so the first thing we do to x is multiply by negative 3. And that's where I made my mistake earlier.
What did you add?
I did the 17. Then we subtract 17. Okay, now reverse those steps.
So you add
Add 17, and then divide by negative 3. Okay, so put your x somewhere over here and do these two things to it. Add 17, divide that by negative 3. Yep, that's it. Yay. Okay, say goodbye.